On question 15, we have another word, a numerical problem. So let's take a look at this. 5, the difference of two numbers. Difference, answer when you subtract. So we're going to say x minus y equals 5. 5 times the lesser number. Well, your lesser number is going to be y, isn't it? So we're going to say 5y minus the greater number, so minus x equals 9. We want to find the two numbers again. And I'm going to do the same thing we did in question 14. I'm going to put my variables in columns. So we have negative x plus 5y equals 9. Notice this one's much simpler than we did last time because my x's are going to cancel when I add them. I don't have to worry about finding common denominators or anything like that. So then, if we go negative y plus 5y, that's 4y. Hate it when I do that, but let's do that again. So 4y, 5 plus 9, that's going to be 14, isn't it? So I divide by 4. Y is 14 divided by 4, which is 7 over 2. You can write that as 3.5 if you want, but I'm going to leave it as 7 over 2. Now let's do the first equation. Y is 7 halves. So I'm going to go x minus 7 halves equals 5. And I don't like fractions. I'm going to multiply everything by 2. So 2x minus 7 equals 10. I'll add 7 to both sides. 2x equals 17. Divide both sides by 2. X is 17 over 2. So we're going to say the two numbers are 17 over 2 and 7 over 2 as a complete sentence. Now here we have an application problem, I think, where we can write this or do this using Desmos. And so on number 16, it says a trail mix costs $2.45 per pound is mixed with a trail mix that costs $2.30 per pound. So what I'm going to do is I think I'm going to let the one that costs $2.45 per pound be X, the one that costs $2.30 per pound be Y. How much of each trail mix must be used to have 30 pounds? There's my first equation. X plus Y equals 30. And then now we'll write one for the money. So I'm going to put $2.45 for the first one, plus $2.30 for the second one. Notice that's going to give me $2.35 for the whole thing, which is 30. Well, I think I'm going to rewrite that second equation just by simplifying. I'm going to take 235 times 30. So if we take 2.35 times 30, we get $70.50. Now, let's graph those two equations because my trail mix, I doubt, will be big, long decimal. Even if it is, we're not going to measure it that accurately, so we could round it. So we're going to graph x plus y equals 30 on our graphing calculator. And in my second equation, It'll be, forget what we said, 245x plus 230y, I'm going to write 2.3, equals, I think we said, what, $70.50, so 70.5. And of course, these are kind of big numbers, so I'm not going to see them all. So I want to click on here where they intersect at. They intersect at 10 and 20. Remember, 10 was the 245. So I'm going to say, as a complete sentence, I want to write this out. We're going to buy 10 pounds. We're going to mix 10 pounds at that costs $2.45 with 20 pounds at $2.30. And that's a 2-to-1 ratio. And then we'll get 30 pounds that sells for $2.35. Okay, number 17. I want to find the speed of the boat. Oh, we're told the speed of the boat in still water is 15 miles greater than the speed of the current. So we take a look here. I know distance equals rate times time. That's the formula I'm going to use. I'm going with the upstream and downstream. And it says the speed of the boat in still water, let's say call that S, well, that's 15 miles greater than the current. Okay, 15 plus C, that makes sense. Now, to find the speed, let's go upstream. When you're going upstream, that'll be the speed in still water, 15 plus C, minus the current. In other words, they told us the speed going upstream is 15 miles per hour. And we know when we're going upstream, we can go 36 miles. So I'm going to go 36 miles equals my speed, which is 15, times my time. Well, let's solve for the time. So I'll divide both sides by 15. I can't do that in my head. So let's take 36 divided by 15. We get 2.4. So we know when they went boating, it took 2.4 hours. Now let's take a look going downstream. Change colors here so we can see it. So going downstream, we know our speed is going to be our speed in still water plus the current. So in other words, it would be 15 plus C plus C, or 15 plus 2C. So then I know my distance when you're going downstream is 60 equals our speed, which is 15 plus 2C. We're going to multiply that by our time, which now we know is 2.4. So now we're going to solve this equation. Let's simplify. 15 times 2.4, notice that's 36, plus 4.8C. So minus 36 from both sides. And we get 24, don't we? Equals 4.8C. I'll divide both sides by 4.8. I can't do that in my head, so I take 24 divided by 4.8. And you get 5 miles per hour. not 5.85. I don't know why I did that. I meant to say miles per hour. Since it's an application problem, let's answer it in a sentence. The speed of the current is 5 miles per hour.